Happy Monday afternoon. Finishing up continuity today. At each point, this continuity state whether f is left or right continuous. So x plus 1, would that have a point of discontinuity anywhere? What about 1 over x? Where is it discontinuous?
That would be at 0.
Is 0 in that domain? So we don't have to worry about it. So that would be continuous over its domain of greater than or equal to 1. Means we only have one point of discontinuity possibly, and that's at 1. First, is f of 1 defined? What is it?
1.
Second condition. Limit has to exist. Approaching 1 from the left, what piece do we use?
X plus 1.
What is that limit?
2.
One from the right, what piece do we use?
1 over X.
What's that limit?
1.
Does the limit exist? Which means we're discontinuous at 1. At 1 is the function right continuous or left continuous? Why?
The only one that reaches 1.
Because that's the one that equals f of 1. X squared minus 3x plus 2 over absolute value of x minus 2. Does that have any discontinuities? Where? At 2. 2's not included. So there's no issue there. Oh, well, this was-
Well,
Is 0 discontinuous?
it's only at one spot.
So is it discontinuous?
That's a great question.
No. So we don't have to worry about that. Only discontinuity could occur at x equals 2.
Well, don't we need to check if the other parts on the top function approach 0?
That's why I said it's possible discontinuity at 2. Now it's just a matter of checking, is it actually discontinuous at 2?
Okay.
First condition, f of 2. Does it exist? It does. What is it?
0.
Second condition, does the limit exist? Approaching 2 from the left, what part do we use? Which one? We're approaching 2 from the left. What do we know about the values of x minus 2? It's going to be less than what? Values of x minus 2. I agree the values of x are less than 2. What about x minus 2? Right, they'll be negative. So absolute value of x minus 2 becomes 2 minus x. What happens if you plug in 2?
Get over 0.
Hmm?
Over 0.
What over 0? It's a determinant. How do we evaluate it? Remember, indeterminate does not necessarily mean does not exist. What does it factor to?
X minus 1, X minus 2.
How's that going to simplify? Limit of what? What's that limit? Now approaching 2 from the right. Same thing. Approaching 2 from the right, what do we know about x minus 2? It's positive. Again, if you plug in 2, you're going to get 0 over 0. And what is that limit? Does the limit exist? We're discontinuous at 2. Is it right continuous or left continuous? What is it? Neither. Now, why not look at a 3-piece function? X cubed plus 1, will that be discontinuous anywhere?
No.
No. Negative x plus 1.
Should also be no.
Negative x squared plus 10x minus 15.
Again, I don't want that one.
Good. Then the only possible discontinuities are where the function splits, which is 0 and 2. Which means we have to check both points. Let's start with 0. F of 0, is that defined?
Yeah,
What is it?
that's 1.
Approaching from the left. What's that limit? Now approaching from the right. What is that limit?
1.
Does the limit exist?
Yeah.
What's the limit?
1.
Second condition is satisfied. What's the third condition?
The limit equals 8.
The limit equals what?
It's called the function. Yeah.
Is that f of 0? 0 is not a discontinuity. Next up, 2. Does f of 2 exist?
Yes.
What is it?
1. Silence is very sure.
I could just check my notes instead of doing mental math.
Alright.
What is that limit? Why do I write 1 there? 2. What is that limit?
One.
Does the limit exist?
No.
2 is a point of discontinuity. Right or left continuous? So right continuous at x equals 2, and it's continuous at 0. That's determine the value of c that makes this function continuous everywhere. X squared minus c. Is there anywhere that would be discontinuous?
No.
What about 4x plus 2c?
No.
No. So the only point we have to worry about is 5. Right? So 3 conditions. F of 5 has to exist. Are there any values for c at which f of 5 would not exist? No. The limit has to exist. What does it mean for the limit to exist?
That means that at this point on both of the functions, they would have to equal the same thing. Weights, like, they have to equal each other if we set x to 5.
What has to equal each other?
X squared minus cn, or x plus 2c.
Technically, no.
Technically. Right, of course.
It's ultimately what's going to wind up happening,
So that was my next time.
but not mathematically.
So we solve each equation for C and then take the equation.
Did we set them equal to each other at any point? No.
Well, I do agree there's going to be an equals.
Okay.
Wouldn't you just have to have f of x or x approach c?
X approaches C.
Well, yeah, when you do the limits.
I wouldn't use X approaching C. But you're close because it does involve limits. What does it mean for the limit to exist at a point? What has to be true?
The left hand and right hand.
Your two one-sided limits at that point have to equal. That's what you said, equal to each other.
So just
That's what we're checking. Why am I doing that? So what is the left-handed limit equal to?
Squared minus c.
And what's 5 squared?
25 minus c.
What does the right-handed limit equal?
Plus 2c.
Solve for C. Last question. That has to equal f of 5. So 25 minus 5/3. So 70 over 3. $20 plus 10/3. $60 plus 10, 70 over 3. So the limit's 70 thirds. What's f of 5? Well, it's 20 plus 2 times 5 thirds, which is 70 over 3. So c equals 5 thirds would make this a continuous function. Two x plus 9x inverse, x less than or equal to 3, negative 4x plus c for x greater than 3. Values of c that would make this a continuous function. Why? Huh? That doesn't matter. What about the negative exponent? So the value of c that makes that a continuous function. What's the left-handed limit? What is it? What is the right-handed limit? What would that make C? What's f of 3?
9.
What is the limit? Is the limit also 9? F of 3 is defined. So it's continuous at 3. Is the function still continuous? Is it continuous everywhere?
We're doing an inversion of 9x over there. That would be what it denominator, right?
Is that what a negative exponent does?
I remember correctly. Where's that? Oh no, that's negative, right? So there should be something that makes sense. 0. 0. Yeah, check.
No value of c makes this function continuous. It's discontinuous at 0. No matter what value of c you use.
You mean we didn't have to do all that?
Nope. Now you're all sad face because you just did work you didn't need to do. Discontinuous at x equals 0 for all real numbers c, meaning there's no solution. I agree that 21 makes it continuous at 3, which is nice. There's nothing at 0. So I don't know if that's a typo on the source, or if that's actually what they intended. I don't remember.
Well, I think they wanted to have situations we had where we worked for everything. We think to ourselves, yes, I mean, it is continuous. We did it. And then you look a little closer.
I'm not sure if that's what the source actually intended.
It's funny.
But it is fun. Now I could alter this. If I do that, now c equals 21 would be the answer. And again, I just don't remember what the source intended. It's been years.
What source is this anyway?
one of the many books I have at home. I have at least a dozen calc books. I'll stick with that and say no solution. Yeah, let's look at a three-piece function. I could go further. Here we need make a slight grammatical change. Oh, perfect. Find values of the constants that make this continuous. So now the question is, are you going to fall for the same trick? Or are you going to check before you do any work? It is continuous over the entire domain. Right, x inverse would only be discontinuous at 0. Well, there's no 0 in either of those two pieces. And ax plus b is linear, which is continuous everywhere. So now there's only 2 points of discontinuity to look at, -1 and 1/2. Oh, that's good, because we have 2 unknowns that we have to solve for. So we have to have that. And we have to have that. Both of those equations must be true simultaneously. Limit as x approaches -1 from the left is what? What about from the right?
That too. Oh, no, we're still on the other ones. What about, yeah.
Limit as x approaches -1 from the right.
-9 plus b.
And limit as x approaches 1/2 from the left.
A over 2, and then not over 2 plus b. Plus b.
That,
And that has to be equal to 2, yes.
and then limit from the right. So let's rewrite that. Hmm? More specifically, system of what kind of equations? Hmm? I mean, that's method. Linear equations. Method of elimination wouldn't work on nonlinear systems. So this is a system of linear equations. 2 equations and 2 unknowns. You only know one technique right now to solve that. And that's the method of elimination. When you take linear algebra, it becomes a lot easier. Gauss-Jordan reduction would be the best. How does method of elimination work?
You guys make the opposite of each other, equal variable opposite.
Yes. That's ultimately the goal, and then what do you do?
And then you cancel out the variables.
How?
So this is what b. So I take one b negative, and then plus or minus b is obviously 0. So you cancel both of them out, and then solve for a.
Right, so how are you canceling them out? What are you doing? Hmm? Multiplying by a number? And then what? Because they don't just cancel out. You have to do something to get them to cancel. What do you
equations together?
Constant times one of the equations added to the other equation gives you an equivalent system. And equivalent systems have the exact same solution. So it doesn't matter which equation you multiply by. Let's just multiply the first equation by -1 to keep the a's positive. So you get a minus b equals 1. Add that to a over 2 plus b is equal to 2. A plus a over 2 right, negative b plus b is 0 equals 1 plus 2. What's a? A would have to be 2. Now you do backward substitution. Pick any of the 2 equations. First one is clearly superior here. Actually, no, it doesn't matter, does it? Because 2 over 2 is going to be 1. So it actually doesn't matter. That one might actually be better. So 1 plus what is 2?
0. Wait.
Oh dear.
1.
So b has to be 1. A equals 2, b equals 1 guarantees that the 2 limits exist. Well, no, because the way that we set it up guarantees now the limits are going to exist. Because the 2 one-side limits are going to be equal. The question is, do the limits equal the function evaluated at that point? What is now the limit as x approaches -1? Well, that's easy. It has to be -1. Like, because that's what the left-handed limit was, and we just guaranteed that the limits are equal until the limit exists. What is f of -1 using that a and b?
-1.
It's -1. What's the limit at 1/2. Would have to be 2, right? Again, using that A and B, what is f of 1/2? It's 2. So that is a valid solution. So that would be a solution. AB is, the ordered pair AB is the ordered pair 2, 1. Questions on continuity? I'm going to go back to looking at evaluating limits. This point, you could do substitution to see what you get. However, we're going to pretend that we didn't just do continuity and we don't know the composite function theorem. So I need one of those neuralizers. Well, you're too young for that, apparently. To understand that reference, yeah, from Men in Black. The original one's still the best. That came out in what, the 90s? Yeah, I'm old as hell. Still remember when that movie came out. Well, first thing, let's factor out a 1/8. Now multiplying by 1. Because remember, multiplying by 1 doesn't change the value. So you're allowed to multiply by 1. And then do a change of variable. So let theta be 5x. Actually, I'm not going to use theta. I'm going to use my favorite Greek letter. Psi. If you know why that's my favorite Greek letter, brownie points.
Sounds like something.
It has something to do with your favorite number. A personal reason you wouldn't be expected to know.
Exactly. Well, you might know it, but not as my reason. Look up Schrodinger's equation from quantum mechanics. Schrodinger's uncertainty equation. It involves psi. Specifically, it involves the partial derivatives of psi. So that's my favorite Greek letter. Oh, you looked up Schrodinger's equation? And it's not hieroglyphics, it's actual letters.
Yeah.
It's symbols, operators. But it's going to be absolute gibberish to you unless you study quantum mechanics. And even then, it might be gibberish. I'll teach you a life lesson. If you meet someone who tells you they understand quantum mechanics, you've learned one thing. You've met a liar. We don't understand it. We just accept that it works and move on with our life. We don't know why it works. We just know it does. As x approaches 0, what is psi doing?
Also approaching 0.
Psi also approaches 0. That makes these two limits the same. What's that limit?
So that one specifically would be 1. Like you multiply that 5/8, the final answer would be 5/8.
That limit is one of those special limits. That's 1, and so it's 5/8 times 1, which is 5/8. That's our limit.
So if we see signs something over something, no, that has.
Your idea is to try and get it as sine of a function over that exact same function, because that will be 1. Hmm?
Like SIMC is that just the sign of a function that's divided by that function.
That I'm not sure. I'm not saying it's not. I've just never come across it.
Yeah, I just looked it up. It's a thing.
It's not something I've ever come across, so I don't know where we used it. Unless they use it as a shorthand.
That's all it is. It's just
Probably because it occurs so often in certain applications.
I guess.
Pi over half.
So now we're being measured in degrees instead of radians.
Oh, right.
The method that was used prior, so the method used to derive sine of x over x, as x approaches 0 is for radians, not degrees. So you can't just immediately say that, yes, this is 1. How would we convert degrees to radians? Because that's ultimately what we're going to have to do. Who remembers the conversion factor? And this was studied in pre-calc.
There's a 360 somewhere in there.
There shouldn't be. What is the actual conversion factor? Or what is the actual relation we're going to be using? 1 radian. It's not incorrect, that's not typically how we represent it. Generally starts off as pi radians is 180 degrees. And then from there you get your conversion factor depending on which way you want to go. The reason we don't do 360 is because it can simplify. You'd write 2 pi as 360 degrees.
I think I was taught
Simplifies to pi equals 180.
Yeah, I think I was taught that way. I just forgot.
Yeah, so it starts off that way. It starts off with 2 pi radians is 360 degrees, and then we simplify from there. So the pi radians equals 180 degrees is the conversion factor. Oh, by the way, it's not typically written that way either. It would be written that way because radians is unitless. It's a placeholder. Right, so if we say pi and pi radians, they're the exact same thing. The reason we have it is if you're doing angular velocity, it just sounds weird to say something like the angular velocity is pi over 2 per second. So we say radians per second because it just sounds better. So we want to go from degrees to radians. So how many radians would x degrees be? How many radians are in a single degree? Pi over 180. We have x degrees, so how many radians is it?
Pi over 180 times x.
Pi x over 180.
write that multiplication, right?
I hope so. That's typically used with angles.
What about delta?
We don't usually use that with angles. Actually, I think there's only 3 we ever really use with angles. Theta, phi, and pi. Or theta, phi, and psi.
One of those.
That could be really confusing.
And just use pi for both of them.
Mhm.
Yeah,
Because pi is a Greek letter.
yeah, that's one of that too.
Could use pi. That was really evil. Ooh. Use sigma. Which should set stat people off. Because sigma has a specific meaning in stat. What is it? Standard deviation. Sigma squared is variance. If it's a population. Sample uses a little less for some reason. As x approaches 0, what's sigma doing?
It's also approaching 0.
And what is that?
Well, if that's in radians, that's just 1.
Sigma is in radians, isn't it?
Yes.
Which makes sense. It should still be 0 degrees is the same as 0 radians. So it better be the same, right? I'm actually just gonna double check that. I left my notes at home. No, it's not. Okay, so what did I screw up? Oh, you know what? That's what I screwed up. It's actually only the one in sine that we have to convert. Still using that sigma.
So I'm sorry, can you go over something?
Yeah, I converted both x's when I should have only converted the one in sign. So there's actually not a lot I have to change. If sigma's pi x over 180, what is x? Sigma's pi x over 180, so what is x?
Just X.
Solve for x. Solve for x right here.
Sigma 180 over pi.
Factor out the 1 over 180 over pi. That limits 1. What is 1 over 180 over pi? How does that simplify?
180 over pi.
1 over 180 over pi. It's pi over 180, it's the reciprocal.
Oh, I thought you said 1 over 1 over 180 pi. That's it.
Yeah, that would be different. Limit pi over 180. Because that second x, that denominator x, isn't really an angle that you're measuring. It's only what's in sine. That's why I checked, 'cause I thought I screwed up. I didn't remember getting 1 in my notes. So there are 2 I didn't get to, but that's okay because we've done ones that look like that. So those will be left as an exercise. See you tomorrow.